Hey, this is Harshan Vijay, and this is my physics lab for constant velocity. So the purpose of this lab was to observe the motions of an object. In this case, my object was a ping pong ball at a constant velocity. I was able to use tracker and glow script software to achieve this. Glow script created a line of predicted data, and tracker used to create a line of the observed data. Then I inserted both of these data sets into a graph, and I analyzed the differences. So here's on the left the ghost whip model that was created after I input the code. Inside the code, I put the mass of the ball, which is the ping pong ball, which was 0.0027 kilograms, and I had the vector position from the observed data that was observed, and I had t, then I had delta t as 0.01, then I had the acceleration and everything else at zero because there was no acceleration, and I will include this in the later slides. Fnet vector was 0, because there's no Fnet forces. There's no net force. So this is an example of the tracker software that I used. Here's the video of the ping pong ball, and here is the I manually had to show the ping pong ball moving, which is basically why it's basically a linear line, because it was moving at a constant velocity. There are other factors affecting this, which I will talk about later. And here's the data that was generated from the motion of the ping pong ball. Here's a Google Sheets graph that I used when I inputted the data. Here's the predicted position and the observed position from the tracker model and the glow script software. As you can see, the observed position is a little less than the predicted position. We will explain why in later slides. So the fundamental principles of this lab was first the Newton's first law. Newton's first law shows that an object in motion will stay in motion unless it is acted upon by another force. Therefore, from this diagram, we can show that the soccer ball is at rest here until someone kicks it, and then it's in motion, and the object will continue in motion at a constant speed until it's acted on by another force, which in this case is the net. So after the net acts on the ball stops moving. This also works with the second fundamental principle that we will use, which is Newton's second law. Newton's second law shows us that the momentum principle, that the acceleration is dependent on net force and mass of the object. This law shows that F equals ma, which means that net force is equivalent to the product of mass and acceleration. The object is moving at a constant velocity, so the net force is zero. Therefore, the acceleration is also zero, so the net force is zero. This is the equation that was derived, and this is F net equals delta P over delta T, two equations that were derived from that formula. So the reasoning is that the position versus time models were a good visualization of the constant velocity from the glow script software. The tracker software was accurately able to determine the change in position with relation to change in time. It was pretty similar, pretty linear to the glow script model that was done. We assumed that friction was negligible because the net force was zero, which means there is true constant velocity because acceleration is zero. The reasoning behind Newton's second law, this proves Newton's second law mathematically because the velocity is constant throughout the object's motion. It was in constant velocity, and there was no proves the law because there was no force acting on the ping pong ball, and the ball was still able to remain in motion. The systems and surroundings in this experiment was the ping pong ball. The surrounding was the desk it was on and the earth. The earth has no net forces because as the ball moves horizontally, therefore there's a normal force on it which cancels it out. So the earth has no effect on the net force. Initial conditions and calculations, I calculate the initial velocity from the tracker software using the data points that I showed you previously. At x final, there was 0.165 centimeters, and at x initials, 0.125. And if you do it 0.165 minus 0.125, you can calculate the initial velocity to be 1.1764 meters per second. Similar with Newton's second law, Newton's second law is pretty similar because it shows that the observed was pretty similar to the glow script model, and this basically proves the second law because in constant velocity, there is nothing stops an object. A couple of errors that could be possible in this experiment was, for example, friction between the ball and the desk, human error when I use a tracking software to mark each movement, or even air resistance. The graph shows that like the observed position is less than the predicted position because the predicted position doesn't include the friction or air resistance or the manual marking. So that means that obviously there could be some differences between the predicted and the observed position. So for the questions, what if you flip the axis if plus x and minus x were interchanged? If you flip the axis from plus x to minus x, the object will be traveling in the minus x direction about the same rate. So it would start near the origin and travel to the bottom of the left quadrant. If you're to interchange the y-axis with the negative y-axis, it would start near the origin and travel to the bottom of the quadrant 4. So in either case, it would still be linear, but it would be traveling in a different direction. For the next question, what does it mean if it's possible for you to show how many pushes and pulls were added together to give the zero net force effect and that you observed? It's pretty much impossible to determine the exact amount of push and pulls because the net force is at the zero. There are lots of forces like friction, air that act on the system. The object is also able to accelerate and decelerate marginally near the end, which means that the net force is actually a little more than zero. Conclusions were that Newton's first and second law, the momentum principle, since there was nothing acting on the object in constant velocity, it still moved in constant velocity. Discrepancies between observed and predicted are apparent because of the reasons I stated previously, because of friction and air resistance weren't calculated in the predicted models.